So hello everyone. I'm the today's lecturer Song Jin Jung, and today's topic is resistance and powering, which is part of the
Can you speak up louder?
okay, it's proportion devices. So this is the list of the book contents, and today we are going to deal with the proportion devices. So first is Reynolds number. So as you guys already might be familiar with the Reynolds numbers. Reynolds number can be expressed by these like mathematical terms. So let me use the laser form. So this is the velocity of the flow particle, and this is the dimensional length. And Reynolds number is divided by Reynolds number is represented as this term divided by dynamic viscosity. So when you do the math calculation, and Reynolds number can be referred to as dynamic pressure divided by frictional stress. So high Reynolds number means like, so high Reynolds number means like dynamic pressure is higher. So the flow can, when the fluid particles go through the plate or in the pipe flow, such as like in the figure right here. If the dynamic pressure is large, it can overturn, so it can make the turbulence. So it will convert from laminar flow to the turbulence flow. So high Reynolds number means lower friction, and it can develop the vortex in a wide range scale. And this means also that higher level of effective diffusion. And the next dimensionless number is Freak number, which is really important for ship dynamics. So Freak number is the definition of Freak number is like this one. So dynamic pressure divided by gravity. So actually the Freak number means like how much thrust power it needs for the ship to make a power against the resistance, such as the friction or wave flow. So high Freak number means lower gravity effect, as you can see from the denominator. And lower gravity, so it means large deformation of free surface, and effect of static pressure is relatively small for planing and semi-planing ships. And this is the one of the propulsion devices called screw propellers. And this is a basic function. And this one, like as you might guys already be familiar with this function. And this one converts torsional energy into the thrust. And this is the terminologies related to propellers. There are suction and pressure signs, and leading and trailing edges, like here, and then top, root, and tip. And also there are diameter, pitch, slip, skew, and rate. And this is same slide. And this one is also the same. So there are 4 types of screw propellers. First one is solid propeller. The next one is controllable pitch propeller, and then supercavitating propeller. And the last one is counter-rotating propeller. So this is the figure of controllable pitch propellers. And this is the counter-rotating propellers. And there is a cavitation and erosion problems. This is actually root cause for the propeller. So when the propeller rotates in a high speed, it makes the fluid to have a high speed. And as you guys already know, that high speed fluid can make the pressure low. So this can make water to the boiling point, even in a low temperature. So the water fluid particle becomes the vapor, and the volume of that becomes extremely larger, so it can damage to the propeller. So usually it happens locally in a pump, on propeller blade, and hydrofoil. So this is the, I guess if I present, this is the figure related to the supercavitation. And the water, if the pressure gets down, even in the like low temperature, it becomes a water vapor. So this is a table for the types of screw propellers. And other propulsion devices are below. And this is the old, I'm not really familiar with this propeller, but it's sort of what we're talking. So actually, this is the end of the lecture that I prepared. So if you have any questions, I would be glad to answer it. Thank you.
Right.